it not let me record? There we go. Okay. All right. So these notes, it's the same section, section 4.1, distance to midpoint, but today we'll be looking without a graph. If you just want to jot down just a little graph right here that has 2 points on it, and those 2 points, I'm going to call them x1, y1, and x2, y2. You can actually put your points anywhere on your graph. Mine, you'll know, that one I put on grid lines. This one I put kind of in between. You can just put them anywhere. It doesn't have to be on graph paper. You could just do, a quick, because what we're using right now is just to sort of see where the formula comes from. Okay? So it doesn't have to be on graph paper because these points could be any 2 points. Yeah, anywhere. And one of them is going to be labeled x1, y1. The other will be labeled x2, y2. And you guys up front, if my head is in the way, let me know. When I stand up, sometimes my head gets in the way. Yeah, all right. Whenever we have 2 points, what we do is we look at these, yes, x1, and they're subscripts, they're little numbers at the bottom. They're not exponents, but they're subscripts, and that just tells us, that's not mathematical, it's just telling us, the first x and the first y, and then the x2 and y2 is, the second x and the second y. So, it doesn't do anything mathematical there, like square something or anything like that. So we've got this line right here, and we want to know the distance of that line. And so what we would do is, if we were doing this problem, we'd make ourselves a triangle, and you might have drawn your points in a different place, so just make yourself a triangle. You might make it look like mine, or it might look a little bit different, but we just make ourselves a triangle. Okay? And so, I'm going to show you where the formula comes from, because I have some students that really don't like, distance formula is kind of a long formula. They're really bad at memorizing things. They don't like to memorize things. So, I'm going to show you how you can do this with the formula, or how you can do it kind of without the formula. Okay? So, this horizontal side right here, normally I would just count how far that goes, and actually I guess I could probably count the way I've graphed it, but I told you guys you don't have graph paper, I just told you to put it wherever, right? So, if I can't count it, then I could still find what it is, and I could find that by doing x1 minus x2, or x2 minus x1. It doesn't really matter which order those two are in. But I could subtract, and that would give me the length of this side. So right here what I did is I just subtracted the x's. And that's for our horizontal side there. And for the vertical, anybody want to take a guess at what you could do for the vertical? Yep, y1 minus y2. Subtract your y's. And now I do need to tell you here that it's not going to give you the right sign necessarily. You might do y1 minus y2 and it might give you a negative number. But whenever we do Pythagorean theorem, we have a squared plus b squared equals c squared. So when we square a number, what happens to the sign? It's always positive, right? Because if we have negative times negative, it's positive. If we have positive times positive, it's positive. So even if this gives you the wrong sign, even if it gives you a negative number, it's going to be positive when you put it into Pythagorean theorem. So normally we would do we would do a squared plus b squared equals c squared. And so I'm going to plug in what I've got, which is x1 minus x2 squared. So this stuff right here, this stuff right here, that's my a. So I'm just replacing the a with x1 minus x2. And then for my b, if I let that be this side right here, I'm going to replace that with y1 minus y2 squared. And that equals, I'm going to call this side right here d for distance. So I'm going to call that d squared. Okay, so here what I did for that is I just took this stuff right here and I replaced that b. Oh, no. Oh, I highlighted the wrong thing. I took this stuff right here and I replaced it with b. So that y1, y2 replaced that b. Okay? So I subtracted the x's. I didn't write this down, but I subtracted the y's. And then I did Pythagorean theorem. So we're solving for the distance. That's the side right here, d. So I know this is a big, terrible looking equation, but if I want to get d by itself, I've only got to get rid of one thing. I've got to get rid of that square. How do I get rid of that square? I square root both sides. So if I square root both sides here, then I'm going to get the square root of x1 minus x2 squared plus y1 minus y2 squared. Is it okay with you guys if I put this d over here? I just don't like it on the left-hand side. Okay, so this right here, this, put a big box around it, maybe some stars, make it sure it's very obvious. This is your distance formula. So there's two ways I'm going to teach you how to do this. I'm going to teach you the formula way, and I'm going to teach you the non-formula way. So without the formula, if you think of what I did, I subtracted my x's, I subtracted my y's, and I plugged it into Pythagorean theorem. Or we can just use the straight formula. The key to this for the formula, though, is this formula will not be given to you. So if you use the formula, you have to have the formula memorized. Okay? So you have to know that formula. Alright, so let's do a problem. Okay, I'm going to give you a second. You can go ahead and copy both of those if you want. Yeah, just give yourself a little bit of room to work. The first question. I'm going to do it two different ways, and you can use whichever way you would like best. So my calculator, these numbers. Obviously, example 1 is not one you can graph. You're just not going to be able to graph numbers that big on any sheet of graph paper that they're going to give you. So for this, we can use the formula or we can use the non-formula way. I'm going to start with the formula. So the formula is the square root of x1 minus x2 squared y1 minus y2 squared. And that 1 and 2 for the x's and y's do not do anything mathematically. All it means is the first x and the second x, the first y and the second y. So this is your first x, this is your second x. This is your first y, this is your second y. Or you could switch that around. You could make this the first x and this the second x. It really doesn't matter. All that matters is that with the point, if this is the first x, this has to be the first y. You can't have first x and second y. Okay, so the points that go together, they have to have the same, if they're both the first x, they have to be both the first point or they have to be both the second point. They can't be mixed up. So all you'll do is plug in your numbers. Okay? So you will have negative 16 minus 43 squared plus 29 minus 21 squared. You do not individually square each number. Because order of operations, what we would have to do first here is we'd have to do what's in the parentheses. So, and you can type this whole thing into the calculator, but I find when students do, they mess up a lot of times. So I'm going to do it one step at a time. So I've got negative 16 minus 43. So I've got that c equals the square root of negative 59 squared plus 29 minus 21 is going to give me 8 squared. And at this point, I will get the calculator out. Let's see here. Sorry to Ian and Jennifer. So if you don't like the formula, this way works just as well. Subtract your x's, subtract your y's, do Pythagorean theorem with those two numbers. Okay? So it's up to you whichever one you want to do. Okay? Questions? Alright, so our next one is in context a little bit. On a map, the library is located at 14.5, negative 2.4. The high school is located at 16.2, negative 1.2. Each unit on the map equals 1 mile. What is the distance as the crow flies from the library to the high school? This phrase right here, I have found sometimes is something you guys have not heard. Anybody heard it before? As the crow flies. Okay? Who's heard it? Heard it? What's it mean, Gabe? Okay? Not really, but it could, I guess. No. If a crow needs to go from Elkin High School to the library, does it have to follow the road? It just flies, right? So we're talking straight line distance. So for example, to go from here to the elementary school, you've got to go out here, you got to go down the road, you got to cut across, you got to go up the hill, right? So not a very far distance, but you got to go this way. But I can open my window and I can look at the elementary school over there. So the crow would not go out here, go down the road, across by the park, up the hill by the fire station. A crow would not do that, right? So a crow would just fly straight there. So whenever you see that phrase, as the crow flies, so when you hear, or whenever you hear old people say it, because old people probably say it, it's the old people saying. If you hear that phrase, as the crow flies, it means the straight line distance. Not following the roads, but just going from point A to point B if you could go in the air. Okay? So, like, if we were talking about how far it is from here to the elementary school, we would probably give how long it takes to get there on the road. But there might be something that we're doing. I don't know if we had a drone and we were going to fly over to the elementary school and we wanted to know if it would be out of range or not. Then we would need to know that straight line distance, not how far it is on the road. Right? So, for this, we need the distance using the distance formula, because distance formula is going to give you the straight line distance between 2 points. So, let's see. I'm going to do the other way first this time. Subtract x's. So if we subtract our x's, we'd have 14.5 minus 16.2. And 14.5 minus 16.2 is negative 1.7. Or you could have done 16.2 minus 14.5 and you get positive 1.7. It doesn't matter whether or not it's positive or negative, because you're going to square it when you put it in the Pythagorean theorem anyway. So it doesn't matter which one you put first. There. And then we can subtract our y's. And for that, we'd have negative 2.4. Be really careful when you're subtracting a negative. You have to subtract negative 1.2 there. So really, you're doing negative 2.4 plus 1.2, which is going to give you negative 1.2. So subtract x's, that gives you the horizontal part of your triangle. Subtract y's, that gives you the vertical part of your triangle. Then you're going to do Pythagorean theorem. So you'd say negative 1.7 squared plus negative 1.2 squared equals the distance squared. And so negative 1.7 squared plus negative 1.2 squared is going to be 4.33. And then what's the last step that we've got to do there? Square root. Oops. And so that gave me 2.081 for my answer. So, and it told us that each unit equals 1 mile. So it would be, in this case, we would have 2.081 miles. And I was just making up a situation here. That's not actually our high school to our library, of course. Okay? If you don't like that, do the distance formula. Distance equals square root of x1 minus x2 squared plus y1 minus y2 squared. So we would have the square root of, I'm going to do it backwards, 16.2 minus 14.5 squared plus negative 1.2 minus negative 2.4 squared. 16.2 minus 14.5 is going to give us 1.7. And negative 1.2, that'll end up being plus 2.4. It's going to give us 1.2 squared. And you'll notice I'm not picking up my calculator because it doesn't matter which way you do it. You end up with all those same numbers as you do this. So the 1.2 squared plus 1.7 squared plus the 1.2 squared, that's going to be the 4.33. And so again, we'll get that distance is 2.081 miles. Questions? want you guys to get a little practice before you go, so I think we'll hold off on midpoint formula until tomorrow. So your homework is going to be from the same worksheet you were working on last night, but I do not want you to graph these. These are actually pretty small numbers, so you could graph them, and you can graph them to check your work. But I want you to do these either using the formula that I used here or using the subtract x and subtract the y's. Okay? So I need to see some work for these. Do not just put a number. I do not want these to be graphed. So tonight, from that same worksheet that you guys had last night, I want you guys to do 8 through 12. Now, I might need to tell you one more thing, I guess. Okay, so, I will say, actually, on number 12, I'm going to take back what I just said. Just graph that. Okay, on number 12, I do just want you to graph it. It's much easier. It's asking for area of a triangle. What is area of a triangle? Base times height divided by 2, or base times 1/2 base times height. Depending on where you're at, you would have learned it different. So you'll need that for number 12. You might want to write it next to it. Base times height divided by 2. Okay. Also, all right, listen to me real quick. For these problems, okay, it's only 4 problems, but they are, the first one is just a distance problem. It's simple. 9 is going to ask for the perimeter of a triangle. So we could graph it, but I told you not to graph it. So like for number 9, if you're looking for the perimeter of A, B, C, then you would have to find side A, B. So you would take the points A and B and you would do distance formula, or subtract x and subtract y's Pythagorean theorem, whichever one you like best. And you'll find what AB is. And then you've got to find BC. So you'll use those points to find that side. And then you'll have to find AC. And you'll find those sides. And then you're going to add all those together to get your answer. Okay, we did one like that yesterday in notes, but we were graphing for those. So it's the same idea. 10 is also a perimeter, so you're going to do that. 11 asks for area of a rectangle. What is area of a rectangle? Length times width, or base times height, depending on what you call them. So, do you need to find the length of all 4 sides of that rectangle? You just need to find the length of 2 sides that are next to each other. Okay? Again, you're welcome to graph these to kind of get a picture of what you're looking at, but I want you to show the work of how you did it, either with a formula or by subtracting. So tomorrow's homework, you got to have some work with it. Okay? Questions? All right. You have 10 minutes left. Everybody needs to be working. Okay, what is it? So do A, B, C, A, and find what it is, and then do B and C. So it's like you have to recall that 3 times.
So A and B and C?
A, B, B, C, and then A, C.